everybody.
Hello,
This is Stefano,
and I'm Paolo.
and we are Orastron. So this is our first stream ever. So if you're around, say hi in the chat. Hello, Chris. How are you doing?
Hello.
We're doing fine, thanks. At least I'm speaking for me. What about Paolo?
I think I'm fine.
Okay.
Not really sure.
So we will wait just a couple of minutes to see if more people are coming. We have two followers. It's good enough.
We have 15 subscribers, so it's not bad.
No, on the channel we have 25 now.
25.
25.
But the ratio is good.
Oh, the audio is low. Well, I think we cannot fix it. I'm sorry.
The audio is a bit soft.
We're using an SM57, which we had to place quite far, so luckily we can't fix that. We can just speak louder, maybe.
Wasn't that advertise? Ciao, sound meet.
Sound meet. Okay, that's fine. Excellent. We will wait one more minute, and then we will start. The intro will be relatively short. We have about 15 slides, so maybe it will take 20 minutes, 25, something like that. And it's going to be very, very informal. A very, very informal thing. What else before starting? Nothing.
We are astronomy, you already said.
We are Orastron. I guess it's time.
Okay, I think they already know you. You are the founder of Orastron. And I am the employee and the researcher here. So I am the main developer of Ciaramella, actually. And okay, I think we can start.
Okay, let's go. Okay, so we have smooth transitions. I hope. Maybe not.
We have to speak louder.
Okay, so let's go. So we are developing this new programming language for audio DSP. It's mostly Paolo's work, but I am, let's say, the philosopher behind the language. Let's say it was original an idea of mine, but Paolo has done all of the work, to be honest. So yeah, let's go. If I manage to do it properly. Okay, so let's start with what is an audio plugin. Well, an audio plugin is technically speaking, a collection of code that's glued together in some way. Inside you have some GUI part, which is very evident because you look at it when you open a plugin. But then you also have audio DSP, which is the part that processes sound. So we're talking about both synthesis and sound manipulation. Then we have other code that is required to make this piece of software work in digital audio workstations or in other domains. So what we are concerned with is just the audio DSP part. So this audio DSP part is usually coded in C or C++. At least that's, from my experience, that's how it works in the industry right now. And those languages, for those who know programming, are general purpose languages, which means that you can develop pretty much anything with them, which has some advantages and some disadvantages. One of the disadvantages is that they're not tailored specifically to plugin development, so you will end up spending some time trying to teach, let's say, those languages what you're trying to accomplish. There are other languages that are sometimes used, like Faust, which is textual, or Pure Data, which is graphical, or MaxGen, which has both components, which are domain specific, which means that they already know that you are trying to develop something like a plugin and so on, or DSP code. They are less used in the industry for plugin development, but sometimes they are. So, since there are already these kind of languages, why did we come up with a new one? Well, we have to look a little bit at what DSP code looks like. So DSP code is pretty much different in nature to general purpose code in that it works on very simple data structures. There is very little control flow. By control flow, I mean branching, I mean operations that involve conditions, like if something is bigger than another thing or if two variables are equal and stuff like that. There is very little of this inside, let's say, good quality DSP code. But you have lots of data flow, which means lots of mathematical expressions. So essentially, this kind of programming is mostly about number crunching and less about controlling conditions of things. This is not usually the target for general purpose languages because it's a very niche application. And those languages usually tend to favor opposite use cases in which you want to deal with complex data structures and so on. And therefore, they provide you with abstractions that allow you to better deal with these cases. And you have to write, as I said before, quite some boilerplate code because they have no idea that you are trying to develop a plugin or a piece of audio code. So in our case, we wanted something that is textual and had a small footprint in many ways, but mostly also on the conceptual side, which means it has very few concepts. It can be learned very easily. Something that has a familiar syntax for coders of C, C++ or such languages, because they are going to be used anyway for the GUI and the rest of the code. Something that is very intuitive to use, so that you have concepts that are you use concepts that are very close to the nature of the problem that you're trying to deal with. A syntax that is very focused so that you don't lose time with boilerplate code and so on. And we want to have the least, to respect the principle of least surprises, in which you essentially, if you know the theory of DSP, you can get straight into coding with this language. On the other hand, we also want this language to be, a language, an audio language, to be reusable, modular, and flexible when it comes to semantics, which means that we want the actual code to develop the actual code once and use it as much as possible in your projects, so you don't have to re-implement things in different programs and applications and so on. Then we want to have tools that are stable and that work well with other tools that you might use for coding in general. We want something that is easy to integrate and doesn't want to
Substitute.
Yeah, substitute. Sorry.
If you're alive, yeah.
Sorry. Sorry. Somebody hates me. Something that doesn't dictate the way you should work, or as they say in web development, unopinionated tools. Sorry again. Another cool feature would be to have this free as open source software, because it has many good implications, both in terms of building a community, having a future that doesn't depend on the people who created first, being legally easier usually to integrate in a commercial product or in other open source products and so on. And what we found out is that no such language actually existed before we started with Ciaramella. There are some languages that cover most of these targets goals or properties, call them whatever you want, that we wanted from such languages, but none that fulfills our requirements. So before going into the details of Ciaramella, let's start to point out what Ciaramella is not about. First of all, Ciaramella is not a framework, which is linked to what I said before. Essentially, it doesn't want to dictate the way you should work with it. It doesn't deal at all with GUI. It's not an IDE, so essentially you use your own tools. You don't expect us to provide you with tools that are better than those that exist already in terms of, editing. It's not a runtime environment, which means we will see later, but essentially the code is not run inside the runtime environment, but it's actually translated into code that you can use afterwards in whatever is your project. As said, we are dealing with very simple data structures, so essentially Ciaramella doesn't provide you ways to represent structured data. That's not the point of the language. It doesn't handle events and MIDI specifically. It doesn't provide you with a bid system. It's not many things. But Ciaramella is a language that is domain specific and that allows you to develop DSP code and DSP code only. Essentially, it's a language that is made by DSP engineers for DSP engineers.
All the rest is your problem.
Yeah, everything else is your problem. We don't care. So, what are the design principles that we follow in developing the language? Well, the first one is the Unix philosophy, which has worked well for Unix at least. That is, we want to do one thing and do it well, and we want to keep things as simple as possible. So we follow this so-called KISS principle. Talking about the conceptual background of Ciaramella, we can say that it is a declarative language, which we will see later exactly what it means. But essentially it means that it doesn't force, when you specify when you code, the order of operations doesn't matter. It will be the compiler which establishes what is the correct order of operations. So essentially you just describe mappings between inputs and outputs, and the actual execution, the order is up to the compiler to decide. Another principle that is followed is that it's a block-oriented language, which means that you define blocks and connect them together and compose them so that you can put one block inside another. And this is really, really similar to what people is actually used to with languages or environments such as Pure Data or Max MSP. And then it follows a very well-codified and paradigm, which is the synchronous data flow paradigm, which is, it's something very technical, but in essence it means that it's not imperative programming, it's not functional programming, but it's a very specific kind of programming that's called synchronous data flow. Which maybe we can go into later if you want. Then when it comes to using the compiler at this point, but any tool, the language is defined as a language that is meant to be transpiled, which means the main use case is that you write your own code in Ciaramella and then you convert, the compiler converts for you the code in other languages such as C, C++, and whatnot, and we will see that too later. The history of the language is of course very short because we started last year, but it has some influences apart from the usual suspects such as C, C++, and whatnot, but more concretely when it comes to audio DSP, it's mainly influenced by Faust, not in the syntax or in the, let's say, user experience, but in how the tools are laid out. So, as in Faust, you have this transpilation of code from the Faust code to many targets. Another influence was is Block Compiler by Karjalainen. This is a long story.
How many centuries ago?
No, it was 20 years ago. But essentially, the thing is, there was this language which was Lisp-based and pretty much unknown to this day, I guess, which featured the possibility to have a scheduling of operations that was not dependent on how things were laid out in a very advanced way. Well, I mean, we had to cite it. It's very complicated right now for an introduction to explain why it's linked to that language. And another such language was one that I've developed for my master thesis, which is called Permafrost, which is actually, let's say, the father of Ciaramella, which also, I mean, took this block compiler language and, put away Lisp and simplified many things. So essentially, Ciaramella is the evolution of this stream of languages. And it's more capable than Permafrost and less complicated. And
I think the syntax is very, very simple.
Yeah, the syntax is simpler and the amount of concept is also lower, let's say. So I will let Paolo continue with the rest and I will rest.
Okay, so now we can go a bit deeper in Ciaramella. Okay, let's see if you can hear me. Okay, should be fine now. Okay, so as Stefano was saying, Ciaramella is a tool that is inspired to the Unix philosophy. So our aim is to solve a problem and not create new ones. So if this is a typical plugin structure, so you have GUI, integration stuff, wrappers, glue code, and finally the DSP code, if it is an audio plugin, you will have typically some modules, no? A module that filters, another module that makes oscillator. So the compilation approach is that you code in Ciaramella, okay? Then you compile, and the compiles give you some code, okay? It may be C, C++, MATLAB, JavaScript, and it is very easy to add the new target code. But the idea is that you take the output code from the compiler and you can forget about Ciaramella at that point. So you can integrate that code in your project. So the idea is to not break your workflow. It is to not break your plugin. So you can, so you are not forced to rewrite your plugin again for using Ciaramella. You can use Ciaramella to just code some parts of your plugin, okay? And this is the keep it simple philosophy, I think. So yes, we can go in the code now. We were saying it is easy, and we think it is actually. The syntax is very, very similar to C, or better, similar to MATLAB maybe. So the idea is that you code blocks, like in a graph. Essentially, in a Ciaramella program, it corresponds to a graph, to a DSP graph with you have nodes that do something, and you can connect them. So the idea is this, and as simple as you listen it. And so, for example, here in the first block, we are declaring a one-pole low-pass filter.
Yeah, it's a one-pole low-pass filter.
Thank you, the DSP engineer. And so you declare output, as in MATLAB. You can declare even more outputs. We will see later an example. The name of the block, LP1, and input. Okay. So we have a signal input and a control input. And another idea is that to treat, to consider both constants, audio signals, and controls and constants in the same way. So you can do x multiplied per frequency and whatever. Okay, so
yeah, essentially you don't need to specify which signal is audio, which signal is control rate, which signal is constant. You just treat everything as the same thing, and then the compiler figures out what is what.
Yeah. So okay, the syntax now is declarative. That means that you declare what how a signal gets processed, but you do not say what is the order. So and a consequence is that here in the first line you can use y.
Why?
Why?
In English, it's why.
Was it Greek? Why? Before it is declared. So you here you have a delay. You declare the delay of y. Then you'd say how y is calculated. So this is a simple filtering process. And we even have a syntax to say what is the initial value of a delay. You know. Okay. Okay, then once you have coded your blocks, that we call composite blocks, you can instantiate them, so you can reuse them. In this example, in LP3, triple low pass filter.
Yeah, essentially it's a series of 3 one-pole filters, which gives you a 3.
Yeah, so you can simply call one inside another, and that's it. The compiler will take care of really instancing the blocks and making the right connections, and we will see it also makes some optimizations, but we will see it later. So this is it.
Yeah, and I would say that this is all there is to it. Like this example shows almost all of the syntax. Only conditionals are missing. So you see how simple it actually is.
Yeah. I mean, maybe in the next version we will for sure introduce some types, because for now it is just floating point, 32 floating point, and but it should break the syntax.
We will see. I mean, but we will talk about it.
Well, the idea is all okay. Okay, we can see some live crash if you want. Okay, let me see. Okay, so we have this web editor. We have both command line compiler. And the same compiler is on the web because it's written in JavaScript, so it should work on the web here. I programming this web page. I'm not a web designer, so it may be not so nice. So this is the example we were seeing before. So you code here, and the idea is to leave as many external options as possible. So for example, in this case we are saying here as a compiler option what is the initial block, so like a main, no? Okay, so
Chris, I will tell you here, because we cannot use the same mouse on two screens. The at decorator, the at thing is for specifying initial values. So essentially you're saying that the first value of y for the delay is 0 in this example.
Yeah,
please.
Exactly. So okay, so the idea is you define your blocks, and then you later say to the compiler what is the main. So in this case we are considering LP3 as main, and then you can give a list of control inputs. So you have, in this case you have 2 inputs, x and frequency. And you tell to the compiler that frequency is a control, so it will consider as that, because he will do some optimizations, of course. You may also give some initial values for the inputs, but it's another story. Okay, you should just compile. Okay. And here we gave this. I mean, the web page here lets you try it on the fly. So this is right. In this moment, it is compiled in JavaScript, and can you hear it? Okay. And it generates a plugin with web audio. So it, right. So it is as simple as it is. I was saying, if you want to compile for the other block, you can just tell it to the compiler. Okay, it's working. Okay, here you can also select a microphone, or you select your files if you want, and that's it. I don't know if I can show you some other examples. Some technical stuff. We managed to. He's the DSP engineer, but we managed to program a wave digital filter. I mean, a low pass filter with the wave digital.
If I remember correctly, yeah. But yeah.
Okay, but without going into details, the idea is that I would say the power of the declarative syntax, so that you can instantiate blocks and connect before they are declared, makes easy to code such stuff. So, for example, here you code some components, some blocks, and then you can instantiate them and connect input to output in a very I mean, it would be complex if the syntax was declarative, but in this case it is simple thanks to the declarative nature of the syntax.
Yeah, essentially, for those who are familiar with wave digital filters, for those who are not familiar, let's say, those kind of algorithms tend to be extremely complicated to deal with in such languages, because the input of one block is the output of another and vice versa. And solving, the actual scheduling of operations normally has to be done manually, and it takes more time with the number of blocks that you use. There are ways to go around it, but none that is really optimal as we see it. So essentially, we push this automatic scheduling to such an extent that as of today, I would say that Ciaramella is the only language that allows you to implement with digital filters without having to specify the relationships between with digital blocks in a very explicit way. The only contender could be Reactor as far as we know, but it's of course not open source and you cannot use it inside other products easily and whatnot. So yeah, this was a great fit, and indeed we have published a scientific paper regarding this exact thing.
There is some theory behind it.
There is some theory. Yeah, we look like stupid, and we are, but not completely.
So yes, where is the PDF? Okay. So yes, the magic behind the declarative syntax is that the compiler takes care of scheduling. So you define the graph, you define the connection, but later the compiler finds a proper order for the instructions. So let's look at the compiler shortly. So as I was saying, it is written in JavaScript, and it was surprisingly a good language to write compilers. I mean, it is extremely easy to fast develop it and to test in future and to play around. So as free gift, we have that it works in browser, it works in Node.js. We should have the compiler already on NPM, so you should be able to just use it via npm. So it's called the Zampogna. So npm install Zampogna if you want. And it is extremely small. Actually, I think we reached the 2000. Too much, maybe.
Too much. We had to cut
line of codes. And okay, we have to say that at this stage, both the language and the compiler are a bit experimental. So the compiler will be rewritten to keep it simpler and to ease the maintenance, but it's a technical story. So it is modular in the sense that at some point we have an internal graph representation, so we can just play with the graph and then optimize and makes operation on it.
Yeah, this is quite interestingly similar in a way to LLVM IR, if you're familiar with that.
Yeah. Okay, and finally, and one of the cool things I think is that adding a new target language. So for now we have C++, and we also have some WST2 wrappers that come. So you can basically program in Ciaramella and get a WST2 plugin that is just working. Okay, so you can obtain C++, you can obtain JavaScript. Someone added the support for D. Thank you. We have a template for we have a target code as MATLAB, so you can study the algorithm you are implementing if you want. Okay, JavaScript with a web audio wrapper and so on. We will add others in case, and it is extremely easy to add target language because you are using a templating library that is called .js. So indeed, the guy who added the D, for example, did it in really half an hour, I think.
Yeah, something like that. And he did it on his own without any instruction from us.
Yeah, and the code is not documented.
Yes.
Let's say it's self-documented.
Yeah.
Okay, so the point is, the build process is you write in Ciaramella, then the first phase is the parsing, so you get the abstract syntax tree if you're interested in this, but it's kind of standard. So then you have this generation of graph, so we have an internal graph representation as we were saying. And on this graph, the compiler performs some flattening, so that when you instantiate a composite block inside another, it takes care of that and tries to optimize if possible. And it performs some optimization that are domain specific. For example, it sees what are the sub-expressions, so the nodes that depend only on constants or only on or some specific parameters, and it groups these instructions so that it calculates them only at some point.
Only when needed.
Only when needed, yes. Okay, if you're interested in this, the optimization you can ask if you want, but it's a bit technical. And later, after all this, the graph gets scheduled. So, and it's a static scheduling, so it happens at compile time, of course, so that you get this order of nodes to be scheduled. And after that, there is output generation. As I was saying, you can obtain the code that you can integrate into your project.
Yeah, if I may add, essentially this pipeline allows to get output that is, I mean, the output code to be, let's say, competitive with how one person would do it manually, and probably like an experienced coder would do. So essentially, it actually helps also with performance in many ways that are not really obvious to the newcomer DSP developer.
Okay. So I just want to show you something. If I manage to. Okay.
No,
Is it okay? Okay.
Yeah.
So I just want to show you that. Yeah, here you can compile and execute, but if you want, there is also a section for plugin exportation. Oh, I think something is missing here. Okay, let's try C++ with the OST2 wrapper. You can compile on the fly, and you obtain this. Okay, this is C++ class. You have the header file and C++ file. So basically, you can just take these two files and integrate them into your project. So it wants to be as painless as possible.
Yeah, it's really self-contained.
Okay, not requiring scaling relationships. Okay.
We will answer 2 questions at the end of the presentation.
Okay. It also comes, as I was saying, with a couple of OST2 wrappers if you just want to try the plugin on the fly. But the main thing is this: you obtain the code that you can integrate into your project, and you can at that point forget about Ciaramella. Okay, that's it. I don't know if there is something important.
I mean, yeah, the only interesting thing is that the wrapper code is separated from the actual DSP code, let's say. So the class that implements the DSP, you can just take that and forget about the wrapper and then use it whenever you want.
You don't need these to make it work.
Exactly. No, that's it.
Okay. So at first glance, you can see that the compiler here put things that it takes the constants, for example, here, and it calculates it before outside the audio part. Same goes for the controls or for the expression that depends on controls. For example, this extra variable was automatically created, and it's calculated only when the parameter changes. So we have this kind of optimization that we once used to do manually, but now we automated them so that the audio code is as light as possible.
Yeah, we should still improve it, but that's the idea.
Yeah, you can see that all that code here, this was the wave digital filter, just became this. A couple of expressions, these and these, essentially.
And one of which is only control rate.
Oh, okay, yes. Okay, so someone was asking.
Let's answer the questions at the end.
Okay,
because we are close to the end.
We are at the end, basically. Okay, so some few words on the status of Ciaramella. What's the status of Ciaramella? I mean, it is. We have been using it for
1 year at least. Yes.
1 year at least. So it's working. So you can already use it. But let's say that a stable version will be ready for the end of the year. Let's say, okay, it's written here. And yes, we want to organize things better. So development was just a one man show. So I was just the main developer, and so I developed it internally. But we're trying to standardize the developing process. So we will have a stable and the branches. We won't mess things up. So we will have this stable and then an experimental branch to try new features and so on. So more technically, the things we're going to add are types. So integers, boolean, so that we can do our matrix indexes and
indices. I want to add, because I was thinking about just yesterday, so Paolo doesn't know. We are
just some more work for me. Okay,
yeah, exactly.
That's it.
Usually we use 32-bit floating points, which also George asked in the chat about. But we may also want to use other kind of encodings for signals. I'm not sure at this point if we want to have a generic signal type which encompasses floating point of different widths and fixed point representations, or if we want to have this specified more punctually. We have to talk about it. I think we will go for float in the first version in any case, 32-bit floating point. But yeah, we need to have some discussion to see a little bit which path to follow, because it's not really evident. Of course, if you have any ideas, we have a forum and we have emails.
Yeah, let's say that development is very open at this point.
Yeah, to discuss. It will be less open in the future, especially since we want to crystallize version 1 very soon. So this is the time to make comments and stuff, and don't expect us to accept your ideas, but we will listen anyway.
We can discuss.
Yeah, we can discuss, of course.
I mean, it's for people who code DSP, so
yeah.
Okay. Strange ideas apart. I was joking. Another thing we would like to add is to import external code. So, for example, if you want to code a part of the algorithm in Ciaramella, and another one is already written by you in C, for example, we would like to allow you to import the C part in Ciaramella and get a result. A program that mixes the things.
Yeah, this is extremely important in any case, because using mathematical functions and stuff like that, we will probably do it this way. At the moment, you only have the 4 basic operations, but of course we need everything else. So that is one side of the equation, let's say, and the other part is actually importing stateful code, which is a little bit more complicated, so that you can also import, working pieces of audio code, not just simple functions that do static mappings between input and output. We have ideas. We probably know how to do this.
I was thinking, okay. We will add for sure circular buffers for long delays. We have adjusted the one unitary delay for them at the moment. So support for arrays and matrices. For what? We already have. I didn't say that before, but we already have. Where is it? The if, the conditional, a conditional syntax. Where is it? Okay, I won't make you listen to this, but we added the if then else operator, and we managed to keep the syntax declarative, and it was not trivial, because we're now mixing control flow with data flow. but we managed to keep the things simple. So you basically declare a composite block here, but the branch gets executed according to the condition. So in this case you have this code executing, in the other case no, and that's it. Okay, and the important thing is that you can keep internal to the branch state here. So if you're interested, you should come to Stockholm.
Yes.
Stockholm in June. There is the Sound and Music Processing Conference.
Sound and Music Computing Conference.
What did they say?
Sound and Music Processing. No.
Sound and Music Computing Conference. And I will talk about this our latest addition with a scientific paper. Actually, it appears that this problem wasn't few domain language did this, but we think we get this working. I mean, it is working.
The actual problem is that when you have declarative syntax and very advanced modularity, implementing something that is quite simple in concept, like a conditional statement, becomes really, really complicated without messing up with the rest of the language. But we managed to do it. So, and it's the first time, as far as we know, that anybody can implement conditionals in a synchronous data flow language properly, according to our opinion.
Maybe Reactor did, but who knows how they did it internally.
Nobody knows. And I mean, I don't want to go into details.
But we are this is text also. Okay. So just to end the show, we will add at some point the WebAssembly as target.
We hope to, because it's not that simple. But
it's not simple. We would.
The problem is that we need to make a WebAssembly compiler, because we don't want to use LLVM or GCC inside the web page. That's too much. So we need to develop one from scratch.
Okay, where is it? So at some point we will add multi-rate processing. So we have to invent something for it. Oh, we already have some ideas, maybe.
Yeah, actually, since the blocks, let's say conditional blocks, are stateful, and we also will have the iterative blocks to be stateful, we can actually implement multi-rate processing transparently within the language when we are done with this kind of work. But still, we need some syntactic sugar to be added and stuff like that.
So Christopher is asking, do we have to take specific care?
Let's answer to all the questions.
Sorry. Okay, so at some point we will provide maybe some libraries written in Ciaramella that you can just reuse. Speaking of, we should also add something to add external files. So some packaging system.
Yeah. We need something to. We will see.
Okay, the compiler will be. We will have a more optimization, or we will fix the existing ones. That's it for now. So some pointers the website is ciaramella.dev. We have the GitHub page. So the compiler is written Zampogna. We have a forum, the Orastron, our company forum, that we have some dedicated section to Ciaramella. Okay, that's it.
Let's answer the questions that you had. So let's start from the.
You can show our faces if you want.
No, not yet. Let's leave a couple of minutes. Okay, so.
Let's start from the beginning.
Okay, hello from Greece. Hello, George. We already said hello, I guess. Otherwise, hello. Kalimera.
Hello, everyone.
George, pretty well. Okay. Yeah, Faust is 20 years old. It's really 20 years old. At least the first version. I guess they rewrote it many times, but I'm not sure. Okay, can you expand allora, let's see. Can you expand on the not requiring scheduling relationship? I assume it's more declared. Okay, so I cannot speak for.
Jetting was the Faust one, no?
No, it's not that one. It's C++
Jetting,
one.
Jetting.
Okay, so yeah, I mean, I cannot. I don't know the details of Jatin's library, so I cannot be very specific about that. But the point is that you don't have to name classes. You don't have to say which part is executed before another part. You don't have that feedback operations imply unit delays. All of these in the code of Ciaramella essentially allows you to specify, for example, let's show the resistor with digital resistor. Okay, essentially you just specify the input-output relationships of a wave digital component, and then you use it, and there's nothing else, absolutely nothing else you need to do. Everything else is managed by the compiler, and the mechanism by which this works is generic, so it's not specific to wave digital filters. You can implement, I don't know, for example, digital waveguides or FDTD networks or whatever you have in mind, as long as you do not create feedback loops without delays. The compiler will find scheduling, and that is unique of the compiler of Ciaramella at this point.
It may be very interesting. The first paper we wrote was about the language, but the use case was this of the wave digital filters. So if you want, you can read it. And so basically the compiler just generates the graph and then flattens it, and it discovers the delays inside the composite blocks. So you can create feedback, delay-free loops between composite blocks, but the compiler will go inside the composite block and see if a delay is hidden. In that case, it will correctly schedule it and will not block you. So we say that this is called the flattening, and this is very, very useful for the case of wave digital filters, because you have this kind of nested stuff here. So if you just look at this, you can find delay-free loops, no? But the compiler expands these composite blocks, and finds the hidden delays inside the capacitor, for example.
Yeah,
so and this is very, very modular, so because you can easily reuse the blocks you are coding here.
Essentially, the compiler doesn't work on hierarchies or levels, but flattens everything and then deals with the whole graph, taking care of all operations at the same time. That's the trick.
I had a nice graphics, but it's on the poster.
Let's go forward, otherwise we never finish this live streaming. So would love to know the details on Zampogna, perhaps in a separate video. Oh man. Okay, I mean, Paul is going to Sweden. We should do it remotely maybe. But if you really want to know, I mean, there are the 2 papers that were already published plus the new one that's going to be published at SMC. They should give you quite some insight on how the compiler works.
An overview at least.
Yeah, and then the code is very short, so if you want to read
it... you can just read
it. Yeah, exactly. Probably we spent more words today than the length of the whole compiler.
And it will be written, so it will be less code.
Yeah, I mean, for the stable version, we will have a complete rewrite also to make it even shorter and meaner. Zampogna feature request expert to Julia code. Okay, can you do that? Because we don't know Julia.
Export to Julia. Oh, well, why not?
Yeah, but if George can do it himself, it's even better.
Oh, it will take you really little time.
Yeah, maybe half a day or something.
Let me show them something. So we have okay, this is the code. So point is, you have source. Okay, and then templates. We have the languages we support for now. Oh, Faust is not here because I have still to merge it. But okay, I will do it. So let me show just this. For example, you have this MATLAB function, for example, and this is you just define a structure. You can just in theory. Oh, sorry. In theory, you can just copy paste something and add the one you want. Okay, this is C++. So you have this basic structure and you give it the instructions to what to put there. So it's is really standard and it's very easy to add in your language. So why not add Julia?
Yeah, essentially you take a piece of code that already works and remove the specific parts and replace with template code. Like all web developers do.
The guy that did it for D just copied this and maybe the header and created this and it's very similar. I mean, this is very similar, but I think Julia is not so.
I have no idea how Julia is.
It should be simple, I think.
I don't know.
Okay, but it is for sure a thing we can do or anyone can do. So where is the show? Okay, no, questions. Okay.
Okay, Christopher. Where is the mouse? Here. Would this directly compare to VST or we need to add? No, the actual VST example runs. Of course, you don't have GUI or anything. The template code around is just to give you the bare minimum to test it in a digital audio workstation. Yeah. So it works like that. You just need to build it and add Steinberg VST SDK files that are needed. It supports for double precision. Yeah, I mean, yes and no. We don't know yet. Okay, and types of slippery slope, of course. We have to take specific care of conditionals when we write it, branchless and so on.
What does it mean?
I don't know what you mean, Chris. If you can.
Do we have to take specific care of the conditionals when we write? I think he means that if there is something special. No, you can basically in the what is it? In the branches, you there is nothing special. You can just code here as you were doing elsewhere. So you can here create other blocks. You can create other nested if then else. No, it's thought to be as how to say, as simple as possible. I mean, it is not a special case. So it's just consider this as a block, consider this as another block.
And depending on the condition, one or the other is executed. Yeah, that's it. But of course, maybe we misunderstood the question. So let us know if we answered.
Okay, then you are asking.
Chris, okay, check the papers. Like handlebars. Exactly, like handlebars. Yeah. Templates, just templates. I mean, we couldn't figure out.
Yeah, of course.
We couldn't figure out a simpler way to do it. I guess. I mean, it's used in web development. We can use it here too. Okay, yeah. Yes, I think we answered all questions. Do you have more?
That's correct. Okay, thank you.
I don't know if the actual chat is really real time or it's delayed.
I think the chat. I don't know. Probably yes. Why not? Okay, our first time on YouTube.
I guess so. Let's show our nasty faces. Yeah, so that's it for the time being. As said, the idea is that we will make a stable version as soon as possible. As soon as possible means by the end of the year. I mean, for stable version, we mean that we have something that we can rely on in the future. And the future means 1 or 2 years at least. So we have a tool on which we can build and another branch where we can experiment with new stuff. this first version will be not perfect, of course. We don't expect anything to be perfect ever, but especially this time. But yeah, I mean, that's how things go. We are a very small company, and our possibilities are limited. If you help us, maybe we can go faster, or we can go slower if you're nasty with us. We don't know. But yeah, that's it. I mean, that's the idea. We will take it from there and evolve it, and possibly listen a little bit more to the early users of the language, if there are any. I hope so.
Well, some people for sure tested it and tried. I will try it first.
Yeah, of course. If you have more questions, forum is the best way to talk about it, so that everybody else can participate. Otherwise,
yeah, I would say
emails.
Expect bugs.
Expect bugs, of course.
Many things need to be fixed. The output, for example, is not very tidy.
Tidy.
Okay. But we are very open to discussion, to people who test, people who wants things, and to contribution on GitHub.
Yeah.
And stuff like that. So.
I want also to add finally that our first aim for the language is to use it as a compositional tool for things that we have already developed. For those who are familiar, we have this library of DSP components called Brickworks, which is written in C. And we would like to use Ciaramella as a tool to compose very quickly these algorithms that are pre-made together. That's probably our first commercial use case outside of the things that we develop internally. But of course, I mean, the language is more capable than that already. I mean, apart from importing code at the moment. So we will follow both branches, also in how the language will evolve.
So this pairs with the fact that we add the possibility to import external code.
Yeah, absolutely.
So you basically can import your modules written in C, and you will be able to compose them and instantiate in Ciaramella and integrate with the rest.
Hello, Jackie Jack.
Hello, Jackie Jack.
Too bad that you just found the live chat.
Thank you, everyone.
Yeah, for today, I guess that's it. And it was a pleasure to...
So we got some viewers.
Incredible.
Incredible.
It was a real pleasure for us to stream this, to make this stream. Maybe there will be more in the future.
Okay. So forum is open. You can register. We can.
Yeah, we're saying the same things over and over. So ciao. Goodbye, guys.
Goodbye.